You know, for as long as we've looked up at the night sky, the moon's been right there, our constant companion. But how it got there, well, that's been one of the solar system's greatest mysteries. A mystery that, believe it or not, we might have just cracked.
I mean, it feels so close, so familiar, doesn't it? Yet figuring out its origin story has been a puzzle for centuries. We've had a leading theory for a while now, but there's always been this one crucial piece of evidence that just never quite fit.
So think of this as a cosmic detective story. We're about to investigate a 4.5 billion-year-old crime scene. For decades, scientists had their prime suspect, but a fatal flaw in the theory kept the case wide open, until now. All right, to really get to the bottom of this, we have to rewind the clock, way, way back. We're talking about the very beginning, the chaotic and incredibly violent childhood of our solar system. Just try to picture it, a cosmic construction zone on a scale that's almost impossible to wrap your head around. About 4.5 billion years ago, a young proto-Earth is just starting to form, basically getting built from the wreckage of countless smaller objects smashing into each other. But the really big one, the collision that would change our planet forever, that was still on its way. Okay, so fast forward a bit. By the 1970s, scientists felt pretty confident they had a leading theory for the moon's creation. It was all about this one dramatic, cataclysmic event, an idea some people even call the Big Splout. So the theory goes like this. A proto-planet, roughly the size of Mars, just slams right into the baby Earth. The impact was so unbelievably huge that it vaporized rock and blasted this massive cloud of debris into orbit. And then, over time, all that stuff started clumping together, gravity did its thing, and eventually it formed the moon we see hanging in our sky.
And get this rogue protoplanet even has a name, Theia. It's actually a pretty cool name. It comes from the Greek Titan who was the mother of Selene, the goddess of the moon. Kind of poetic for an event that literally shattered a world, right?
Now, a theory is great and all, but you need proof. You need hard evidence. And that's exactly what the Apollo astronauts brought back. Over 800 pounds of moon rocks. And these weren't just souvenirs. They were forensic clues, straight from the scene of this ancient cosmic impact.
And those samples, man, they told a heck of a story. They showed the moon was once covered in a deep ocean of magma, which totally points to an incredibly energetic birth. They also revealed a tiny iron core and a lack of certain elements that would have just boiled away in a super hot event. It all fit the giant impact theory perfectly, except for one huge glaring problem. The chemical signature of the moon rocks was a near-perfect match to Earth's. And that just didn't add up. And this is the moment where that beautiful, perfect theory starts to fall apart. This one piece of the puzzle, the identical chemical fingerprint, or what scientists call its isotopic signature, it just wouldn't fit. Why would a collision between two different bodies result in a moon that looks like it was cloned from Earth? Here's the thing you have to understand. Every planet in our solar system has its own unique chemical fingerprint. It's like planetary DNA. So if the moon was mostly made from this other planet, Theia, it should have Theia's fingerprint, right? Or at the very least, a mix of the two. So the billion-dollar question was, why does its chemistry look almost identical to Earth's? This was the massive contradiction at the heart of the whole thing. The computer models and all the simulations kept saying the moon should be made mostly of the impactor, of Theia. But the actual rocks, the physical evidence we brought back, they were screaming that the moon was made almost entirely from Earth's own mantle. And that one mystery, well, it stumped scientists for decades.
So, to put it simply, the models predicted a moon that was, let's say, 70% Theia and 30% Earth. But the rocks were telling a completely different story. The only way to make the math work was to assume that Theia just happened to be Earth's long-lost chemical twin before the crash. And the odds of that? Astronomically small. We're talking winning the cosmic lottery small.
So, for the longest time, case went cold. The puzzle was just unsolved. But then, a massive breakthrough. And it all came down to the raw power of modern supercomputers, which gave us a solution that is just stunningly elegant.
So you've got scientists at NASA and Durham University, and they decided to throw an insane amount of computing power at this problem. They ran some of the most high-resolution, detailed simulations of this impact that have ever been done. It's like going from an old, blurry photo to 8K video. They could suddenly see the collision in a way nobody had before, and they noticed details that the older models had missed entirely.
Okay, so remember the old theory? Theia hits Earth, creates a ring of dusty debris like Saturn's, and that ring slowly comes together over months or even years.
Well, these new supercomputer models showed something completely different, something way more dramatic and way faster. They showed that the impact could have launched a huge, mostly intact chunk of material, basically a proto-moon, straight into orbit, all in one go.
And here is the absolute mind-blowing part. The punchline. This new, single-stage formation didn't take years or months. The moon could have formed and settled into a stable orbit in a matter of hours. I mean, that's nothing. It's a geological blink of an eye. All right, let's just walk through this new idea. The high-energy impact blasts a massive chunk, mostly from Earth's upper layers, straight out into space. This clump is made of way more Earth material, like 60%, than we ever thought. It's big enough to hold itself together with its own gravity, and it settles into orbit almost right away. And boom, just like that, the chemical puzzle is solved. The moon is Earth's twin because it's mostly made of Earth. And what's really cool is this idea also helps explain other weird things, like why the moon's orbit is tilted and its crust is so thin.
You know, this whole thing isn't just a cool story about the moon. It's really about us, too. As one of the researchers, Vincent Ike, put it, the histories of the Earth and the moon are just completely intertwined. You can't really understand one without understanding the other.
And that's why this really matters. Think about it. That same catastrophic impact that gave us our moon might also be a key part of the story of how Earth became a world that could support life in the first place. The more we learn about these giant collisions, the more we understand the recipe for making a habitable planet.
But, you know, the story isn't finished yet. This is still a theory, a really, really good one, but it needs to be tested with new evidence. And that's where the Artemis missions come in. When those astronauts head back to the moon and bring back new samples from totally different places, we could be on the verge of finally confirming this incredible new chapter in our shared history. It just makes you wonder, right? What other cosmic secrets are just waiting for us, locked away in those ancient lunar rocks?